Okay, so in this session we're going to spend quite a bit of time understanding the role of lactate as mitochondrial fuel. Now, the reason for doing this is that when we assess endurance performance, aerobic endurance or cardiorespiratory fitness, or even I'm trying to understand cardiopulmonary pathologies, one of the variables that we monitor is the blood lactate response to incremental exercise. And in healthy population groups, athletic groups and so on, what we tend to see is a curvilinear response. So the blood lactate will show a slight rise fairly early on in an exercise challenge, then it will level out, and then we get this systematic or systemic response where the lactate suddenly breaks away from linearity and rises up to a maximal value. But in order for us to understand why we get that response and what that response means, we need to delve into what lactate actually is and understand the role that lactate plays in both muscle physiology, but also in relation to whole body physiology. Hence the domain that we're going to spend time on in this podcast. So to do this, we first of all got to go beyond the convention of a blood lactate response. And we've got to get into the idea and the notion that what blood lactate represents is a balance, or a response showing the rate of appearance and disappearance of lactate. So this is appearance and disappearance of lactate at the cell. And so what you're recording in the bloodstream is whether we have got balance or whether we have got perhaps more appearance than we've got disappearance. And that is a fundamental step change that we have to now move towards. That we cannot simply just conserve this idea that it is just a blood lactate response to exercise. There is much more going on. Tied with that, we've got to start to think about, well, if we are getting appearance and disappearance of lactate, that must mean that lactate per se is moving in and out of cells. And in order for it to move in and out of cells, we've got to look at the idea of the transport mechanisms, whether that is active transport or whether there is a co-transport mechanism involved. So we're going to spend some time doing that. And then the final thing is we're going to deal with this idea of influx and efflux, that's a rate of appearance and disappearance. But actually think about how that is linked to muscle fiber type, particularly of importance to us when we're considering the transport mechanisms, but also when we're considering the notion that in terms of endurance physiology, one would expect that we've got greater recruitment, not necessarily more, but greater recruitment of type 1 muscle fibers compared to type 2 muscle fibers. So all these really go together in terms of drilling down to our understanding of what happens in terms of that blood lactate response to exercise, and in particular incremental exercise.